Hello guys, welcome to my YouTube channel. In today's video, I will show you how to read analog data from ESP32 microcontroller. So before going in in programming side, I will show you some of the important points that you need to understand before I started programming on ESP-IDF. So, what he said is ADC is an analog to digital converter uh, that converts analog signals to discrete signals. So we use uh, analog signal to measure various types of sensors, actuators, and so on. So depending on the requirement, you can use ADC in your project. So in this uh, image, it is showing you a simple use case like a variable resistor uh, connected to analog input. So this is a very basic example of a use case of analog input. So in ESP32 analog input, there are uh, two ADC controllers. So you have to they call it channels. So it has two channels, and in each channels it assign number of GPIOs dedicated to it. So for an example, for ADC1, it has dedicated 8 channels, and for ADC2, it has 10 channels. So if you uh, need to know more details, just Google ESP32 ADC, and this in this link they have explained you the uh, about the ADC ADC channels and other details. So and when it comes to key features, I have summarized very important points that you need to understand before going ahead with uh, the ESP hardware. So in ESP32 ADC, it has 12-bit resolution. That means uh, the range it can the input range can be represented by uh, 4096 distinct value. So basically, to configure the inputs to read the 0 to 5 voltage, so 0 is represent 0 voltage, and 4095 represent what the 5 voltage. So if you want to understand how this value comes, so that is 2 to the power 12. So that is 4096, but it is since it is starting from 0, the range is limited to this value. So this is very important points that you need to understand, and also when you are selecting a GPIO pin from channel 2, you have to make sure that GPIO pin is not uh, using for Wi-Fi module. So if you are using in your project, if you're using Wi-Fi and GPIO analog input. So you have to make sure the the IC, the model that you are using for this your project is not using one of these GPIO inputs. So the information is mentioned in this document. So I highly encourage you to go through this document before get starting on programming uh, the ADC. So, and the other very important setting is this attenuation setting. So, so they have given four attenuation. So that means we can, by changing this variable, we can change the range of input reading. So that is what that is why this attenuation setting has given. So so the maximum is 3.9 is this range in uh, but you can whatever if you want to read 12 volt analog signal, so you can use the voltage divider to step down that voltage into this given setting. So so this is what I mentioned before. The ADC to is shared Wi-Fi module, so you need to uh, keep in mind that uh, if you are using a Wi-Fi with the ADC, so make sure those GPIOs are not using in ESP32 module that you are using. So, so the common use cases using analog is basically to read sensor information like temperature, potentiometer, and also we use audio applications and as well as battery mounting. So these are very few common use cases that we use analog input. Uh, so and when it comes to ESP32 S3 and so currently I am using ESP32 5.2 version, so uh, 5.3 document and these documents are similar. So uh, the reading mechanism, they call it one shot ADC and continuous ADC conversion. So uh, so this you need to understand what is their implementation in the IDF library before going ahead with the program. So uh, in this document, they have very clearly mentioned uh, about the APIs and how to initialize the setting and how to assign channels and the pin GPIOs. So on. So go through this video as well. Sorry, this documentation as well before starting the sample program. So let's move on to IDF and see how the program runs. So, so this is the example that IDF has given us uh, to uh, start as a starting point, given as a starting point. This example can find from uh, by going into this explorer and go to examples, and under the peripherals has, I remember, yeah, here, the two modes, the one shot speed mode and the continuous mode. So I am explaining you today the one shot mode, and you can see what is happening on continuous mode afterward. So to uh, create the example file, just select this and give your folder path, then it will create the uh, create the example file. So since I have already done, I'm going to do it and select your the correct COM port and the ESP32 module that you are using. So currently I am using ESP32 S3 module. So when I have already built the file, so these steps I have explained in my previous video. So if you haven't watched my previous video, please uh, go ahead on those videos as well. So if I explain you this code little bit, so this is macro defined here. So since I'm using S3, the target version is 3, so it has enabled these two definitions. So basically, in this example, is reading channel 2 and channel 3 from ADC1 ADC1 module, and ADC ADC0 channel from ADC2 module, and they have initialized to the buffer to save AD0 and the conversion value. And these are the important steps. So in the main loop, these are the steps to initialize the uh, ADC module and do the configuration. So these things are, you can use these functions directly in our application. You just need to change these definitions according to your use case. So you can see here unit ID there, it is 0 since it is using ADC1 module, and given the bandwidth as 0 and the attenuation is 12. So if attenuation is 12, so that means the range is wait, the attenuation value is dB 11, 12, and there's option to 12, 12 as well. So you can see this option by just uh, uh, clicking this definition with control, and it directs you to the library header. So you can see the settings that is available in the library. So uh, okay, so the attenuation they have setting as 12, and these are the APIs to initialize the configuration, and uh, these to initialize the calibration. So this function is not a standard function. It has defined in the bottom of after the main loop in this example. So basically, if you are making a custom project, you can directly use this function without an issue. So that is why I always telling you, if you want to develop a system on ESP32 using IDF. You just follow these example, even example codes and understand the basics, and you can directly use these APIs and the examples uh, according to your requirement. So you can. So what you need is to understand what is uh, they have done in this example and the use case of each API. So similar to this, uh, it has defined the channel 2 as well here, and if you go down, this is a very simple code, just reading those channels in a while loop, and this is to deinitialize the setting the, after the while loop. So this is very simple, and this is what actually any use case we can even in our program we can use. So depending on the conversion and all of that, you can edit this program and setting uh, prepare the program according to your use case. So let's see what uh, happening once we upload this program to the ESP32. So I have already uploaded by using this button, and let's see what is showing in the serial monitor. So you can see here it is continuously updating ADC channel 2, 3 from ADC channel 1 ADC channel 1 module, and only read the channel 0 from ADC2 module. So you can see the raw data inputs and the uh, real voltage value. So I haven't connected any external voltages, but still you can see a millivoltage in the uh, if you since I haven't connected anything into the analog feed input. So so this is what happened in the code. So uh, if you are creating a project, uh, you may have to setting up these settings according to your input range. So, but the basic concept behind the APIs and the program is this. So I hope you get an understand about how we can starting the analog reading in ESP32. So that is the for my today video. Uh, I highly appreciate if you can subscribe to my channel because it is encouraged me to do more videos like this. So thank you very much for watching my video. We'll see you later. Thank you.